All right, so to start, I'm going to talk through some things to keep in mind for the time series project. As I mentioned, feel free to adjust the prompt. I think those of you who are here, I've already let you know that you can cut down the number of zip codes that you're dealing with, run models for maybe like 4 to 6 zip codes, and then narrow it down to 1 or 2. So these are questions that came up with my last cohort. So I don't know if you are all thinking the same thing, but I think useful to just go over. So the first question here is basically dealing with stationarizing your data before putting it into your model. And I have actually gotten a few questions throughout one-on-ones talking about this. The differencing is not the only method of stationarizing. There's also like log transforms, making use of decomposition rolling means. All in all, mainly dealing with differencing and with seasonality, those two things are dealt with the model as long as you're using a model that can take in seasonal components or the differencing components. So if you're using an ARIMA, you would not have to difference your data before feeding it into your model because the model will do it for you. It will also undifference your data when it's feeding out your forecasts. And same for seasonal components. If you feel like you want to have seasonality in your model, you just have to tell it the seasonal parameters, and your model will take care of that for you. You don't have to decompose that prior to feeding your data in. The only exception is something like log transform that isn't part of the model. If you want to log transform your data to have it be stationary, you're going to have to log transform your data before feeding it to the model. And then the predictions that you do get, you have to unlog. And just to remember, the opposite of logging is taking the exponent. So it's just numpy.exp, and that will unlog your data.
I have a question.
Mm-hmm.
Wait, so you're saying ARIMA differences for you if you find, but don't you have to first like make it stationary or take a look at the stationarity before and maybe difference it on your own to see if that would work to make it stationary?
You're absolutely right. So
and then you would take it back, then you would do the undifferenced data and feed that into the ARIMA model.
Yes, that's right. I know it's a little bit like the back and forth process, but yeah, the differencing is determined by, the model's differencing is determined by the D value that you give it. So to figure out what the D value you give it, you're going to have to difference it yourself first, maybe during your EDA, do the Dickey-Fuller test just to make sure that it is stationary. And then, yeah, you would have to undifference it and then feed it the raw data into your model.
Okay.
I know it's like a back and forth, but the main like pro of this is that you can feed in raw data into your model. You wouldn't have to include pre-processing steps before feeding your data into the model.
But if you feed in the difference data into the model, would it still be the same? I mean, would it still say, okay, it's different already, it looks fine, so they wouldn't really bother with it?
Well, if you difference your data already, but your ARIMA model has like D equals to 1, for example, it will actually difference it again. Okay. It doesn't know that you have already differenced it. So that's one thing to, I guess, be aware of. The also downside is if you pre-difference it before feeding into the model, the results that come out of it will be different data.
Already different, yeah, and then you have to undifference it again yourself manually.
Exactly. It's much harder to undifference something because you would have to start from the beginning and then like add back all of the changes. So because of that, better to do the back and forth during your EDA rather than after your model.
One quick question, Yush. So now let's say if we select 5 zip codes or 4 zip codes, each of the zip codes, we need to convert it into a separate data frame and then work on it, correct?
Yeah, that's one way you can do it, yeah. You can technically, I guess, if you have it all in one data frame, when you feed in the data, you just have to call in the right column. But yeah, keeping it separate data frames works just as fine.
Okay, yeah.
Awesome. So yeah, this has actually come up a good bit in 101. So just wanted to clarify that if you're doing differencing or seasonality, you don't have to difference it or decompose seasons before feeding it into your model.fit. All right, and yeah, you should still find out in your EDA to verify the d-value that grid search gives you. Basically, this is in the context of like, let's say you don't know what your best PDQ could be. You technically could do like a giant grid search or with AutoArima and, you know, find the best PDQ through that. But through EDA, you should still verify d-values that make sense. All right. Another thing that people have come across is the difference between get predictions and get forecasts. This is something that's very, very specific to time series models because time series models forecast, right? You're using past data to predict future data. So just a very like minor difference. Get predictions. Predictions are technically your predictions on your training data. So basically, you know how like when you fit a line through your regression, through a regression data set, you can still have like your train RMSE or your train predictions. That's like what that is. And then forecasts is solely for predicting into the future. And it's into the future of your train set. So in time series, don't forget you have to do your train test split. If you do your train test split and in your test set, you have like your last 24 months of data, for example, that means your data was trained up to like 2 years ago. To get the forecasts, because the last 2 years is not something that your trained model has seen yet, you would have to use get forecasts instead of get predictions. And it's not just for Ceramax, it's actually the same for all of the traditional time series models. So yeah.
One quick question, Yush.
Mm-hmm.
So now there are like in one of the zip codes, there are 265 data points. It's on monthly basis.
Yeah.
Okay. So is that enough data points, or we need to scale it up, or we may need to make it bi-weekly or weekly, and then just take the prediction?
Yeah. For this data set, it's fine to keep it as is. I mean, you also are not able to get more smaller time periods unless you create it yourself.
Yeah, it's only monthly. Everything is only monthly. So
yeah,
checked
you don't have to worry about the number of data points. If they provided 265 data points, that is what you have. And yeah, you don't have to worry about trying to like get more data.
Okay. Yeah, it's like if that needs to be splitted up, and then there is, I mean, I think there is a process of getting that thing done also, like where you split the data and pull, make some forward filling or backward filling for increasing the data points.
Yeah,
Those
I
things
wouldn't worry about that because that's also like kind of synthetic data, so it doesn't make sense to train your model on that.
Okay.
Kind of similar to that point, I know that different zip codes have different number of values. There are some zip codes that have like a bunch of null values. One, if you see that most of the data for the zip code is null values, don't use it, because I know like for this case, we are still arbitrarily picking zip codes based on like region or based on whatever. So feel free to not build models for zip codes that don't have that much data relative to others. In extension to that, doing a train test split, you can be more flexible in this case as well. So for example, if I think 265, as Kishore mentioned, I think that's like the maximum number of like months that we have in that data set. If it's 265, you can do a train test split.
72 is the highest.
Oh, okay.
Yeah, so and
Okay.
most of the data have 270. I mean, not most of them, but like a lot of them have 272.
Okay, yeah. So in that case, the way you do your train test split, you can be flexible with that. Maybe you want to set it standard that you want to have 2 years in your test set. So 24 data points in your test set, no matter what your training length is. So that's something that you can do. I've also seen it done where no matter what the length is, you still do an 80-20 split. Up to you to decide. I don't think it matters too much in this scenario. So keep that in mind, because I know different zip codes have different like number of data points available.
Could you go over the predictions and forecasts again? So we suppose like you do up to, like you have everything but the last 2 years in your training set. Are you predicting just to see how your model did on the test set? You compare the two, or what if you actually want to use this to forecast, well, what should I invest in? Then you would want to use the entire data set, wouldn't you? Like, I was a little confused.
Yeah. So it's more of like getting your models. So getting predictions, you can only get predictions for data points that were in your train set. That's the limitation of get predictions. And anything that is after your train set, you have to use get forecasts. So this will sort of show you like how well your model fits your training data, which I mean, you can also compare your RMSE there. But then, I mean, you're right, it's more important to see how accurate the forecast is, because you are trying to forecast the whole goal of this is to forecast the growth of housing prices in different zip codes. So yeah, they're just different functions for different parts of the data.
And then suppose you do up to like you get the a well-fit model based on get predictions, and then you use a get forecast on that same model. Would you though would you ever want to, and then you compare that to the test set and see how your forecasting did?
That's right. That's right. Okay. So for example, let's say I have like 500 points in my train set. I will use get predictions to see that error there. Get forecast, let's say I just have 24 data points last 2 years. I would get forecasts because that wasn't in my train set. I'll get forecast, compare that to my test set, get my test RMSE. I could even get forecast, do 36 to get an additional year's data to see, all right, after the data that we have, where is that going to go? And that is more used for like forecasting.
Right.
Another approach that you all can think of is after you do your train tests, after you do your predictions and forecasts, and you're sure that your model isn't overfit, and like you've decided, all right, this is the best model for this zip code. What you can do is actually refit your model on the entire data set, just so it has the information for the last 2 years, so that when you're making predictions for the additional 1 year, that isn't included. Exactly, because the nature of time series is that you inevitably will lose forecasting power the more in the future you go. So you ideally want to have as much data as you can, as much data your model is being, you want your model to train on as much data as possible.
Right.
Yeah.
One quick question. So like when we do the Dickey-Fuller test,
yes.
Right? In that, higher number of lags, if it is there, is it better to predict based on higher number of lags, or you have to maintain a certain number of lags and only then it's a good prediction?
So mathematically, the more lags that you do, the less information you have, right? Because with every difference, with every round of differencing that you do, you're only looking at like the change in your price. So you actually lose more and more information. Yes, your data will get more and more stationary. That's just the nature of differencing. Your data might get more and more stationary, but then you're losing the actual movement in your data.
Yeah, that's exactly the reason I asked you is like as the lag increases, the p-value is decreasing.
Always will decrease. Yes. Yeah, so, it's just the nature of
selecting the zip code becomes a challenge, because like there is like the p-value is lower, but the lag is higher.
Yeah.
So how do we select which zip code is better? The lowest.
I think do you mean like selecting your zip code like at the very end out of your 5, or selecting zip codes to use for your model?
To use
for your modeling. Okay, so if you want to, so let's say you already have your 5 zip codes, and let's say one of your zip codes, the best differencing value is like 20 differences. And you get like a really, really solid prediction result, but it's a prediction made on like difference to a degree of 20, which might not make the most sense. That's something that you can actually, that is something you can take into account when you're trying to decide. I would say it's not the most important factor that I would consider in deciding which zip code to eventually recommend. But yeah, you're right in saying that like having a model that does more differencing might end up being less reliable, because you're building your model on the difference of the difference of the difference of the difference time series data. So yeah, that's something you can consider, but it's not the end all be all of like, yeah, this is difference more than 5 times, I cannot use this. Because sometimes you have no choice but to difference that many times.
Okay.
Yeah, and also I would say like when it comes to how much differencing is enough, once you get a p-value that's below 0.5, I think that's enough because you don't want to over difference your data because again, you lose information when you do that. Yeah.
Oh.
All right. This is something that I will not go too much into, but someone found something on dynamic forecasting where basically if you have future data points that you found, you can actually feed it into your forecast. So let's say you're forecasting for the next 12 months. It's going to make the prediction for, let's just say it's January through December. So you get your January prediction. It's going to look at your actual value for January and then take that error into account when you're making the next forecast. So dynamic prediction is a method that is included with all the stats models, time series models, which feel free to, oh, not this one, sorry, this one right here. So feel free to use it if you want, not a big deal if you don't, because it's not always the case that you have data rolling in when you're trying to train a model. So yeah, these two Stack Overflows are here for you to reference if you want to just see how that would work. The next couple of questions, let's see what's useful. One approach that I did talk about is you could cluster your different zip codes so that let's say you end up with like 10 different groups of zip codes, so you can have like a model for each. That is really another method of simplifying this project from like having to run like, I don't know, however many zip codes there are, that number of models. So yeah, don't worry about this part too much because I think all of you here that are doing the time series project are already subsetting the data set. Okay. So I saw, Henry, you had posted this question, and Sawyer, you kind of had an answer on like transposing the data. I know that they had like a pd.melt and like a pivot in there. It's really not necessary to do that. I would say like with pandas, it's kind of like there are many ways to do one thing. So that's a question that came up. So you feel free to take whatever approach is easier. I personally like to use transpose over pivoting and melting anyways.
Yes, but on the project in the repo, that
Yes.
write-up, it actually talked about melt. So I'm just curious, what happens when you actually use melt versus transpose, because maybe using melt got to that point. I don't know, but
yes, I wanted to actually show you all this and to let you all know that this is incorrect. So if y'all saw this starter notebook, which is in the project repo, feel free to look at it if you want. There's actually, I feel like there's not much in here anyways. I feel like it's more confusing than anything in my opinion. This is wrong, what they have here. What they're saying in terms of the text is correct. Like you don't want your data to increase in time left to right. You want it to go top to bottom. But these values are wrong. This perhaps came from using melt. I'm not sure exactly what they did. I don't know exactly what the series of functions they did to get from this to this were, but transpose will get you the right result. So I personally never use melt, so I cannot speak too much as to what it does exactly. But yeah, just FYI, if you see this and you see that your numbers don't match this, it's because these numbers are incorrect. If you see here, these values here.
I actually checked the melt function and it throws different numbers. So
okay, good. So maybe.
Yeah, so transposes I thought like is the best way to get these things done because it just changes the structure. Nothing, it does not do anything with the numbers. It just changes the structure from like horizontal to vertical.
Yeah, exactly. Which is why I like transpose as well, because it just flips your data frame to the right axis. But yeah, as you can see, these values are actually all of the April values here, which is
basically
incorrect.
so melt is possible to use as well, but here melt was just not used correctly.
Yeah, because this is a screenshot and I don't know where they got that from. This result is incorrect, but you
Got
can use melt.
You
And I
can
believe
use
it
it.
would be a combination of melt and pivot.
Okay, that's probably okay. Anyway, okay, cool. Thank
Mhm.
you. It looks like they forgot to do some pivoting. I mean, but anyway, yeah.
Yeah, for sure. All right, yeah. So I just wanted to point that out. That's something that Marv actually pointed out to me. So thanks, Marv, for that. Okay, so I do highly recommend that you try out AutoArima because it's pretty much like doing a grid search for your time series model. Also, feel free to like, if you can get grids, the regular scikit-learn grid search to work, you can do that too. But AutoArima, which I think I had linked it up here somewhere. There we go. AutoArima, I have a walkthrough there. Very, very easy to implement. So for AutoArima, some tips on like running AutoArima. Basically, someone found that the best differencing parameter, and actually this goes back to Kishore's question, someone found that the best differencing parameter for one of the zip codes was like 24. And differencing something 24 times, as I mentioned before, you lose a lot of information every time you difference, so it doesn't really make too much sense. But definitely when you're at the point where you want to try out AutoArima, you basically give it a range of values for your PDQ, your seasonal PDQ to test. Let those values be guided by your EDA, because if you're running like D values of 0 to 24, P and Q values ranging from like, I don't know, even 0 to 10, it's going to take a very, very long time because you're running that many models. So I would say, yeah, it makes sense to plug in the best D value based on your Dickey-Fuller P value. Yeah, but yeah, you do lose information when you difference. And then also usually when you're tuning your differencing values, you tune them with a smaller window, just because you don't want to over difference your data. All right.
Yeah, mine is highest is 15. So, so I mean, others
Yeah.
are around 5, and then like 15 is 13 and
Mhm.
15 are the highest ones.
Yeah, which sometimes for like a certain zip code, if it's just very, very volatile and very like sporadic, that honestly might be the best thing to do in terms of modeling. But take into consideration when you are presenting someone with a suggestion on what to invest in, that should be something that they're aware of. The fact that you're not using the full data to make these forecasts. Cool. All right, so this is basically about like undifferencing your model if you differenced it before putting your data through your model, so I won't go through that. Oh, AIC and BIC, which are the, I like to call that like the R² equivalent for time series models. Just know that they can go negative. Some people are thrown off by that. Negative AIC, BIC values actually mean that your model is doing even better. AIC, BIC are unbounded. So there's no like range. It's not like a 0 to 100. It's not like a 0 to 1 value. It's literally like unbounded. And they're all relative to each other. So yeah, just something to note. Cool. This is all of the like additional questions that have come up regarding time series. Does anyone else have any other thoughts?
Specifically for time series?
Yeah, specific for time series for now.
Okay.
After this, I'm going to talk about NLP.
I guess that was one the differencing. So you're saying that if you difference by a lot, you're going to lose data? Or
It's
because
not
you're
so much
missing
data,
the
but
first,
information. Yeah.
you're missing like this. So if you difference by 12, you're going to lose the first 12 of that data frame.
Yeah. Actually, on that note, yeah, that's right. You do lose that number of data points when you difference that many times.
And is there any other way that you, I'm sorry, you go ahead.
I was going to say that it's like sort of looking in terms of losing data. I mean that it's kind of the difference between looking at stock price per day versus percent change in stock price per day. You lose that like actual information of like the exact price, if that makes sense.
Okay, right. I see, because it's more about the change, but more about the difference than the actual price. But is that true too if you difference by one time?
Well, one time, I mean, yeah, because one time you're going from like actual price values to the change in the price values for the for what's real estate. So yeah, you're kind of losing information. I will say differencing it once, it's easy to difference that, but the more that you difference, and imagine like you difference something, like even like differencing something 5 times, which is that means like the change and the change and the change and the change of your time series. If you're fitting a predictive model on that data, like there's still a bit of disconnect, because you're in the end you're trying to predict the change of the change of the change of the change, not so much actual price values.
And then also but and also if your difference is by 12, it used to 24, but also that if it's seasonal, that could mess things up too, right?
Yeah.
Like if something's like, you know, every Christmas something happens, it goes up or goes down, whatever.
Yeah, yeah. Because actually when you difference, you might lose seasonality. You might lose, like if you have like normal like yearly patterns, if you difference it too much, you actually might lose that pattern, that underlying pattern.
Okay. So in general, be careful when you difference and don't do it too much.
Yeah, yeah.
Okay.
Okay, well, maybe one, maybe two. So first question that I have is can you explain exponential decay factor a little bit more?
Where do you see exponential decay factor?
Oh shoot. Wow. It's I think it's related to the weighted, what's the name of that? It's the weighted not the rolling, what is it? Rolling mean, not the rolling mean, but it's the weighted, what's the name? I can't remember the name right now, but it's the weighted, it's not the rolling mean or the rolling standard deviation, but exponential smoothing. So it's related to that.
Okay.
So,
all right.
So it just explained a little bit about, well, there's exponential decay, and it has something related to the weight you give to the most recent years of the time series, or maybe it's it makes it where it's less, like the older the year for the time series, the less weight it has.
Yeah.
But I was still a little confused as to what was happening when it comes to exponential decay factor. I didn't really know.
Okay. Honestly, as this relates to your traditional time series models, I don't recall how exactly that plays into your time series models, or if that is even a component that you can include. Off the top of my head, I don't remember this. I actually remember exponential decay from like learning about time series in economics. And the whole idea is that, yeah, as you were saying, you want to give more weight to more recent data, because things in the past, like let's say 10 years ago, are much less relevant to making forecasts than things that happened like yesterday. So that's the whole idea of exponential decay, and reweighting the importance of your data points based on how far back in time that happened.
So decay,
to be honest,
no, all I was going to say, because just to make sure I couldn't, that's why I asked, just to make sure I can explain it, is so decay factor is basically describing the weight or the value of a particular year or particular point in a data set in a time series. It's like how, like the factor at which the weight that it has in terms of the whole modeling, the older that it gets or the further away it gets from the present, basically.
Yeah. To my knowledge, the decay factor specifically is the rate in which days become less important the more in the past they are.
Gotcha.
That's for like decay factor specifically refers to that.
Gotcha. Okay.
But yeah, the overall idea behind exponential decay is, yeah, the further back in time you have, the less important those data points are.
Got it. Okay, thank you. And then one other question I had was, like, when I saw when I did the seasonal decomposed visual, when I working with the seasonal decomposed visualization, I saw that the years could be off in the visualization. Is it possible to to set a parameter in the visualization so that the years are lined up?
Good point. Let me see. I think it's from stats models, right?
Believe so.
Seasonal decompose. I think it it really depends on their underlying. So if you're using this, I don't think there's a way to edit the graphs. Let me see. Yeah, it doesn't look like you can edit the graphs.
Right. I was just wondering. Okay.
Yeah,
no
not
worries.
in a straightforward way though. Like I think you can actually recreate this because I believe this actually uses matplotlib, if I'm not wrong. So there is a way to recreate it and like customize it to line up the way that you want it to, but I would say not worth it for this project.
Right, for sure. Okay.
Mhm.
And I think that might be a scene at the time for time frame shows no trend. And this just last one is just really related to just language because I was reading in Learn.
Mhm.
It says this particular time series has no trend. So I think it was related to saying that it was stationary, right?
Yeah.
So my question, it might be a crazy question, but anyway, I don't care. So if I looked at if I decided to look at a more specific period within that time series that they said that they said, well, okay, it's stationary, it has no trend. Technically, is it possible to look at a smaller window of the time series and then find a trend?
Yeah, that's actually a very common approach when you're doing traditional time series modelings in stocks. So for example, like I've had a couple students do this time series project on like stock data. And for them, they're seeing that your models perform so much better if you model it on only like the past year's data versus 10 years, because just like overall
it
trends are
has
going to,
stationary. Right.
yeah, and your model will try and fit linearly, especially if you're doing the traditional time series models. It's kind of linearly fit to all the data. So if you have a period or a subset that is still a good enough number of points, that is much more stationary versus the entire data set, you can definitely subset it.
Got it. Absolutely. So then
Mhm.
when in terms of the language that's used, when it says that this particular time series is stationary and has no trend, it's specifically related to the starting point and ending point of that time series.
Yeah, that's right.
Okay, it's not okay. Because if I change, because I could literally change it, let's say from, if it was from January 2020 or 2010 to 2020, it's like, oh, stationary. But then if I just change to March of 2010 to March of 2020, I very much so could find that it is not stationary at all.
Yeah, it's
Okay.
possible, especially if you have like a shock in like.
Exactly. Okay,
Yeah.
just wanted to make sure about that. All right, that's it. Thank you.
Yeah, that actually also like kind of ties back to like exponential decay, because points in the past, whenever you're looking at time series, become less relevant just by the nature of time. Awesome. So next I'm going to talk about NLP. I know actually a bunch of you, a few of you have told me that you want to maybe consider NLP for your capstone. So I do think it is relevant to talk about. So let's take a look at some of the questions that have come up with the NLP project. And just for some context for you all here, the NLP project, you're basically given a bunch of tweets relating to this tech conference that happened, I think it was like 10 years ago in Austin, South by Southwest. And at this tech conference, Apple and Google were showcasing their new products. And at that time, it was, I think, the iPad 2 and like Google Circles, that like social media app from Google, like 10 years ago. So that's what a lot of the tweets are about. They were manually labeled positive, negative sentiment, or neutral. And yeah, the task of the project is to classify based on words. Can you build a classification model to see if a tweet has positive or negative sentiment? So a couple of things that have come up in that discussion. Let's start from Dana, because I think it gets more complicated. So with NLP, especially if you're using a bag of words model, and just to recap, bag of words model would be any data frame that you're feeding in. Each column is represented by a different word or a different token. That's a bag of words model. As long as you're feeding in that kind of data frame into your model, it's a bag of words model. Usually it's count vectorized or PFIDF vectorizer. If you use that, you can actually extract feature importances to literally show you what the most important words are for determining something to be positive or negative. So yeah, basically it's the same process as getting feature importances in your mod 3 project. So yeah, you can actually get your actual words from get feature names from the vectorizer if you want to match it up. So that was something that came up. I don't know if I'll save word embeddings for later because I don't think word embeddings is definitely not a necessity for this project. But let's talk about LDA. LDA, I think, even though it's not part of the curriculum, I think is a very, very powerful EDA tool. And for those of you who don't remember what LDA looks like, I'm going to show you all an example. Let's see this one. So this you can apply to anything. And this is a visualization that you can extract. So for any set of text, LDA is a model that performs what's called topic modeling, which is basically trying to extract what are the main things that people are talking about within a set of documents. So in the context of this project, with all of these tech-related tweets, what are people talking about? And within positive and negative, you can actually do an LDA for each one to see, all right, for all the positive tweets, what are people happy about? For the negative tweets, what are people not liking? And from this, it actually takes into account like the meaning of the words as well and groups them together. This, if you create your own LDA model, this will be interactive, so you can actually hover over the different clusters. LDA is also a clustering model. I forgot to mention that earlier. So each of these is a cluster of tweets, for example. And then when you hover over, it'll show you what the main words are within each cluster. And from that, you can usually infer some of the topics that are being discussed in like positive or negative tweets. So I do think, even though this is not in the curriculum, I do think it is a very, very useful EDA tool because you actually get a sense of what people are saying. So yeah, I do have the code for LDA in my study group notebook on your repo. So if anyone needs to refer to that, that is all there. Another thing that came up with this is also in, hold on, let me just quickly remember what's happening here. Yeah, instead of LDA, because LDA is a clustering method, feel free to try out like k-means clustering or HAC for your NLP project. You can definitely do that. But it will be, your results might be slightly different because whereas LDA will focus on things that are being said, k-means will just do it mathematically based on your word frequencies or your PFIDF values. Yeah, actually, I feel like the NLP project is pretty straightforward. The hardest part of NLP is the actual NLP process, which honestly, during capstone phase, most of the additional sessions will be going through NLP processes because that's what people find the most difficulty with. So look out for that. But yeah, at this point, any NLP related questions? All right. Actually, my other cohort is about to present their capstones in a couple of weeks and a lot of NLP projects there. So I'll let you all know when that is happening and they will be recorded too. So yeah, I think it'll be really cool to see what they're doing.
Yes, why do you think so many people in the capstone are doing NLP? Is it like related to the market or what?
I think partially related to the market. NLP is a field that is, I would say, is one of the hotter fields within data science right now. I would say the part that is growing is not so much this stuff, because this NLP stuff is quite traditional. A lot of new NLP models are coming out that are very, very powerful, like models that will do translations for you, or like models that can, they're very like advanced, like predictive text models. Actually, someone in that cohort is building a chat bot with like a pretty intense, utilizing a pretty intense NLP model that has been pre-trained by Google or something. I think Google. Yeah, but anyways. I do think it is partially due to it being one of the faster growing fields in the market right now. Also, I think with NLP, it's easy to do for a capstone because with NLP, there's a lot that you can expand on. Like there's almost like an infinite amount of EDA that you can do, and people are generally curious about words because it's easier to interpret or be curious about, you know, what are people saying in like I don't know, in like reviews or in comments and tweets. I think there's just like a natural curiosity to finding out how to quantify what we're seeing in text data, because I think that was something that more traditionally was not accessible. So I think because of that, I will say NLP is also like very hit or miss. I think you either love it or there's like a subset of students that just does not want anything to do with NLP because it's a very, very different, it's a very different form of thinking. Like with NLP, the way that you look at your metrics might be different based on context. And yeah, happy to talk about these when we get to capstones. But yeah, I think NLP is really interesting just because of like all of the technological advancements that they're using right now. Like they're using like, yeah, I've read a bunch of Medium articles lately that are doing some pretty crazy things. Like they're using NLP models to help with like image data as well, which is how powerful it is, how you can translate models that are used for text into models for images. There's something that I saw that was pretty neat where they use a model that is traditionally used for NLP and it's for image completion, which is very, very, I guess, specific and niche. Like I wouldn't think, why would anyone need image completion? But basically given like half an image, it will generate the other half of an image, which is pretty cool. Since we have time,
using NLP.
Using a model that was traditionally used for NLP.
Got it. Wow.
Yeah, I think here I have it. I have a link here that I can pull up. It's super neat. So as an example,
OpenAI, got it. Yeah, I've seen. Okay.
The input image was this half, and
Wow.
it basically has generated the bottom half of all of these images, which is wild. I mean, some of them are kind of weird. Like, for example, like this baby seal has like teeth now. But for the most part, the fact that the bottom halves of these images were just generated by models is insane.
That's so interesting. Oh my goodness, for so many different reasons that I'm gonna get into now. But yeah, no, that's pretty great. Now, the only other kind of related question that I had is you mentioned how somebody is like they're implementing an NLP type of model, and I think you actually mentioned it for this project is if we were gonna do NLP that we wanted to really kind of read up on some of the other things that are being done outside of the curriculum, right? Mm-hmm. In terms of like any of the other areas, like time series, for example, is it in terms of what's out there now and being used now? I saw an article about time series as it relates to like a lot of people are using time series during the pandemic for a lot of different things that were happening for industry and stuff. So my question for you is everything that we're doing with time series as far as the curriculum, like, do you recommend we pull is there something else that we could maybe think about pulling in or, you know, or something like that? Or is it just, is it aligned with the current stuff that's out there now?
Yeah, so time series, I think I'd mentioned before that the traditional like ARIMA kind of models, they're very much still used in more traditional industries like finance and real estate just because of the interpretability. For more accurate predictions, I think time series, even the other topics like not NLP, recommendation systems, and what was the other one? Oh, I guess image classification is a neural network, but they all are now starting to use neural network technologies to do different tasks. I do have a few resources actually linked here as well on, is it linked here or is it linked in the time series? Or I might have it linked in my guidelines for the capstone, which I will send to you all when the capstone time rolls around for you guys. But yeah, for time series and rec systems, all neural networks now. If you want to have like high accuracy predictions, there are a lot of good walkthroughs on how you can implement them. So you can definitely try to implement them if you want for this project. I would say not a priority, but could be like a future work or like next steps that you can incorporate. Even like those NLP things that I showed you all, those are also neural network based. So I think neural networks is kind of where things are moving towards in terms of the products that are being created. But you, again, as I mentioned, you lose interpretability. You have no idea why the images are being generated that way. So yeah, pros and cons. I do think that it is still important to be familiar with like the traditional models, because I think a lot of the underlying foundations of neural networks for time series still draw on the concepts that are within traditional models. So long answer is there's a lot out there, but what we're learning is important too. All right, anything else? All right, well, to end off, early next week, I'm actually putting together a panel of my former classmates who are all working as data scientists right now. I'll be moderating like a little Q&A, and I'll send you all invites to that as well. I'm going to be posting a message in Slack either later today or tomorrow morning, doing a call for questions that you would like to ask them, just so I can have them see if they want to prepare things to say. So if you have questions that you want to ask current data scientists, these were all former students who did the program as well. So if you have questions for them, start thinking of them. So when I post that message, I would like to take questions just so I can summarize what people are looking for. All right, so that's probably going to happen. I think right now, this coming Tuesday evening, will also be recorded for you all to look back on if you can't make it. But yeah, just wanted to give you all a heads up that that's happening. Cool. Any final questions to close out?
What time it will be?
Still confirming. I'm thinking probably 7 p.m. Eastern, just because they all work. So probably 7 p.m. Eastern time.
Perfect.
Cool.
Awesome. Just to remind you all, next week there will be 2 more office hours, but then the week after there will not be office hours because you're technically in cohort break. So yeah. Cool. Anything final before we close out? Okay then. Well, have a good night, everybody. As usual, Slack me with questions if you have any.
Thank you, Yish.
Bye, guys.
Bye, everybody.